Okay, so we have our Ferris wheel. Radius of 10 meters makes one rotation every 20 seconds. So we're assuming all the people are loaded on, so they're just running it. I want to know what the apparent weight of a 750 Newton person at the top and at the bottom of the Ferris wheel will be. So 750 newtons is the actual weight of the person. That's the force of gravity. mg equals 750 newtons. So m, the actual mass of this person, (76.5 kilograms). So at the top, person sitting in the car, the chair, whatever you want to call it. There's definitely a force of gravity, and there's a normal force. What direction is the normal force in? Up. The chair's pushing up on the person. Person's not upside down. So when we write our equation, we're going to have force of gravity minus the normal force. Because I'm going to call the direction towards the center of the circle, I'm going to call that my positive direction. Because my acceleration is towards the center of the circle. So that's why I'm writing it as force of gravity minus normal instead of the other way around. You can, if you do not like doing that, you can say normal force minus force of gravity, but you have to put a negative sign on the acceleration. And that's fine, you get the same result. But like I said before, I tend to forget that little negative sign, so I find it easier just to call towards the center of the circle positive. So this is at the top. So force of gravity is mg. Centripetal acceleration is v squared over r. So what are we looking for? The normal force. The normal force is the apparent weight of the person. That's what they feel. So the normal force will equal mg minus mv squared over r. Notice the bigger v gets, the smaller the normal force will get. There's going to be a maximum speed that this Ferris wheel can spin at where they would actually start lifting off the seats. I don't believe they ever get anywhere near that on a Ferris wheel though. You can feel it in a roller coaster. This would be the same case of a roller coaster where you're sitting upright the whole time. As you go up over the top of the hill, you may start to lift off the seats because it's going so fast. Okay. Now V we need to figure out. We know it makes one rotation in 20 seconds. Well, one rotation is how many meters? 2 pi r. So 2 pi radius, I said, was 10 meters over 20 seconds. V will be pi, basically, right? I'll leave it at pi for now. So the normal force at the top, mg is 750 newtons. That's the actual weight of the person. M we figured out was 76.5 kilograms. V we just found out was pi meters per second. R we said is 10 meters. Okay, I'm a little challenged here, sorry. 674 newtons. Please let me know if you disagree. So this person feels like they weigh less. You feel lighter at the top of the Ferris wheel. Your body wants to keep going in a straight line. That inertia wants you to keep flying away. But the chair keeps you coming down. And gravity, of course. At the bottom, the picture is the same, though. You have a normal force up, and you have gravity down. But I imagine from experience, you've noticed that when you go down through a dip, whether it be on a roller coaster or the Ferris wheel, you feel heavier. So what is it going to be different? Something's got to be different about this equation. Yes, the acceleration is pointing upwards, towards the center of the circle. So if we follow that same rule and call towards the center of the circle positive, then we're going to have the normal force minus the force of gravity this time. So the normal force will equal mg plus mv squared over r. Certainly. Certainly. So the normal force in this case is 826 newtons. It's bigger. They feel heavier.